Hey everyone, and welcome. You know that little lock icon you see in your browser, or how your private messages actually stay private? Well, that's all thanks to something called encryption. It's this kind of invisible shield that protects our entire digital lives. And today, we're going to pull back the curtain and see exactly how it works. Let's get into it. Okay, just imagine this for a second. What if everything you did online, every single private message, your bank details, all your passwords, what if none of that was private at all? It's a pretty terrifying thought, right? And it gets to the heart of one of the biggest challenges of living online. How in the world do we keep our private stuff, well, private? Well, luckily, we have an incredible answer to that question, and it's called encryption. You can think of it as this silent guardian, this invisible shield that stands guard over everything we do. It's a process that takes our normal data and just scrambles it into a secret code so that even if someone gets their hands on it, it's just complete gibberish to them. So how does this digital magic trick actually work? Let's dive in. All right, so to really get this, we first need to learn the secret language of encryption. And the absolute foundation of that language is a concept called a block cipher. Seriously, this is the engine that drives so much of our modern digital security. So what on earth is a block cipher? Honestly, the best way to wrap your head around it is with a simple analogy. Let's imagine there's a secret club, and this club, of course, needs to send secret messages. They have to make sure nobody can eavesdrop on their plans, so they don't just write things down in plain English, no way. They use a special members-only dictionary, a secret code book. Now, this club has one super important non-negotiable rule. All their messages have to be broken down into chunks or words that are the exact same length. Let's just say, for our example, every single word has to be exactly 8 letters long. If you have a word that's too short, you just add some filler letters to pad it out. This rule, this need for uniform size, is absolutely key. Okay, so once you've chopped your message up into these perfect 8-letter blocks, what's next? Well, you take each block one by one, and you look it up in that secret dictionary to find its secret code word, its scrambled up equivalent. That dictionary, the book of rules that tells you how to do the scrambling, in the world of encryption, we call that the cipher algorithm. But wait a minute. What stops someone from just stealing the dictionary? Wouldn't they be able to read all the messages then? That's a great question, and here's how the club handles it. To stay one step ahead, they get a brand new, updated dictionary every single week. This weekly edition, this special, unique piece of info that you need to make sense of the messages, that is what we call the secret key. If you have last week's dictionary, it's totally useless. You need the right key for the right lock. And that's it. That's the core idea. So if we strip away the whole secret club story, what are we left with? Well, as you can see right here, a block cipher is just a method that encrypts data in fixed-sized blocks. The big takeaway is that it doesn't try to scramble the entire message all at once. Instead, it works on these nice, neat, uniform chunks, one at a time. Okay, so we've got the big picture idea down. Now let's take a tour inside the encryption factory to see how this assembly line actually works, step by step. It's really a simple 3-step process. First up, conversion. Your normal message, what we call plain text, gets turned into the language computers speak, binary, just ones and zeros. Next is division. That long string of ones and zeros gets sliced and diced into those equal-sized blocks we just talked about. And finally, the fun part, encryption. Each and every one of those blocks gets put through the Scrambler using the algorithm and that all-important secret key. It's systematic, it's efficient, and believe me, it is incredibly powerful. So the block cipher method is like the blueprint for a fortress. But what's the actual fortress that everyone in the world trusts? It's time to meet the undisputed champion, the gold standard of block ciphers, the Advanced Encryption Standard, or as you'll always hear it called, AES. I mean, it is almost impossible to overstate how important AES is. This isn't just some obscure tool for tech folks. It actually became the global standard after winning this massive 5-year-long public competition to find the absolute best, most secure, and most efficient algorithm out there. Today, it's the official standard used by governments, including the US government, and it's the bedrock of security for pretty much every bank, tech company, and major industry on the planet. When security really matters, AES is the answer. So let's look at the numbers here, because they're pretty important. As you can see, AES always works on a fixed block size of 128 bits, no more, no less. But when it comes to the secret key, that secret dictionary, you get a choice. You can use a 128, 192, or 256-bit key. And trust me when I say, the bigger the key, the exponentially harder it is to crack. We're We're talking security on a whole other level. And maybe the coolest part? This incredible world-class security is totally public and royalty-free. Anyone can use it. So where is AES actually working in your life? Well, pretty much everywhere you look online. You know that little padlock in your browser when you're on a secure website? That's HTTPS, and you can bet AES is probably working behind the scenes. Using a VPN to keep your browsing private? Yep, AES is creating that secure tunnel for you. And the data on your phone or your computer? If you have disk encryption turned on, that's almost certainly AES locking it down. It is literally protecting you right this second. This quote on the slide really says it all. AES is the backbone of modern symmetric encryption. It's not just one option among many. It is the foundation. It's the steel frame that almost all of our digital security is built on top of. It's that important. All right, let's wrap this up. We started with a pretty simple idea, a secret club with a special dictionary, and we've seen how that simple concept scales up to become the digital fortresses that protect us every single day. Okay, if you remember just one thing from this whole explainer, make it what you see on this slide right here. It's the difference between the method and the standard. A block cipher is the how. It's the idea, the general recipe for chopping data up and scrambling it. But AES is the who. It's the world's most famous, most trusted, most battle-tested implementation of that recipe. Think of it like this. The block cipher is the blueprint, but AES is the actual, finished, impenetrable fortress. So let's do a super quick recap. What are the big takeaways? First, block ciphers work on fixed-size chunks of data. Second, it's a three-step dance: convert, divide, and encrypt. Third, AES is the undisputed king, the global standard for block ciphers. And most importantly, number 4, this isn't just some abstract theory. This is the tech that's actively protecting you right now, every single day in your browser, your VPN, and on your devices. So now you know. You've basically pulled back the curtain on one of the most important systems keeping our digital world from falling apart. And it kind of makes you wonder, right? Now that you can see this invisible shield, what other invisible systems are out there, quietly working behind the scenes, protecting and shaping our world in ways we don't even realize?